You just told your AI assistant that your quarterly report is due Friday. It agreed to remind you. Next session, it has no idea what you're talking about. LLM conversations start fresh. There is no persistent state. Every message goes into a context window with a hard limit GPT-4 at 128,000 tokens, Claude at 200,000, and when the window closes, everything disappears. You could dump your entire conversation history into every prompt, but a year of daily use is roughly 3 million tokens. That's $20 per message. Memory has to be smarter than that. Think of a two-drawer filing cabinet. The top drawer holds every conversation you've ever had, one file per day, chronological, plain markdown. The bottom drawer holds a single curated reference card, the key facts about you, your preferences, your ongoing projects. Every time you send a message, the bottom drawer goes into your prompt unconditionally. The top drawer gets searched, not entirely read, just searched for the 3 or 4 entries most relevant to what you said. OpenClaw calls this episodic and semantic memory. Episodic logs everything. Semantic carries the essentials. The insight is knowing which drawer you search and which one you always carry. Episodic memory is the top drawer. OpenClaw writes every conversation to a markdown file named by date, YYYY-MM-DD.md, 1 file per day, appended chronologically. What did you discuss? What did the agent do? What was the result? When you send a new message, the system searches these files using a hybrid retrieval algorithm. It does not read them all. It searches. The output is a ranked list of short excerpts, not whole files, just the relevant passages. The thing engineers consistently underestimate. These files are human-readable. You can open yesterday's log like a journal. OpenClaw also auto-loads today's and yesterday's files unconditionally before any search runs. That's your working memory, always available, no retrieval cost. Bottom drawer is different. OpenClaw calls it semantic memory, a single markdown file called MEMORY.md. This file is curated, not logged. It holds facts the agent should always know: your name, your role, your preferences, your ongoing projects. MEMORY.md goes into every system prompt unconditionally. No retrieval, no ranking, it's always there. That costs tokens on every call, which means it must stay short, typically 1 to 5 kilobytes, around 1,000 to 5,000 tokens. Here is what most people miss. You edit this file yourself. The agent can suggest additions, but semantic memory is human-controlled. That is not a bug. It's the only way to prevent the file from drifting into noise over time. When a message arrives, OpenClaw runs 2 search operations over the episodic logs simultaneously. BM25, implemented as SQLite FTS5 full-text search, scores each chunk on keyword overlap. The BM25 rank converts to a score as 1 divided by 1 plus the rank. Rank 0 gives a perfect score of 1. Rank 9 gives 0.1. Vector search using SQLite Vex0 virtual table computes cosine similarity between the message embedding and every stored chunk. The 2 scores combine, 70% vector, 30% BM25. Then temporal decay multiplies the result. A note from today scores at full weight. One from 30 days ago scores at 50%. One from 6 months ago, roughly 3%. The highest scoring diverse chunks go into the prompt alongside memory. MD. 3 failure modes. First, memory degradation. Episodic logs fill with noise, small talk, failed tool calls, repetitive exchanges. Retrieval starts surfacing noise instead of signal. The fix is selective logging, record what the agent did and what mattered, not every token exchanged. Second, latency stacking. Retrieval adds a round trip before the LLM call, typically 80 to 150 milliseconds. On fast models, retrieval takes longer than inference. The fix is parallel search. Run BM25 and vector simultaneously, not sequentially. Third, privacy exposure. Every conversation gets logged to disk. On a personal self-hosted machine, that's acceptable. On a shared server, episodic logs become a liability. The mistake most teams make is not defining the log boundary before deployment, not after an incident. The complete memory pipeline. A message arrives at the gateway. Two operations run in parallel. First, memory. MD loads unconditionally the curated facts always present. Second, hybrid search runs over the episodic logs BM25 plus vector weighted 70/30 multiplied by temporal decay. The top-ranked chunks combine with memory, MD and conversation history to assemble the full context. The LLM call goes out. The response returns through the channel. Afterward, the exchange appends to today's episodic log. Every time you design a memory system for an AI agent, ask 3 questions. What do you store, how do you retrieve it, and what do you always carry? Log everything. Search selectively. Carry the essentials, that's the entire model.